This conference will now be recorded.
Yeah, can you hear me, guys?
Yes, we can hear you. Good morning, Shiva.
Good morning, good morning. How are you?
Alhamdulillah, I'm okay. How are you?
Good, good. Just give me 2 minutes. I'm searching for a document.
Okay. Yeah, no problem. Take your time.
Somewhere it must be stored. Material, symbols. Already. Somewhere I stored this. Okay. Now, why most of the persons are absent today? Because this is very important class, right?
Right.
So, what is Kubernetes and why Kubernetes? So before understanding Kubernetes, what is the need of Kubernetes? First, let us discuss. Okay. So till this point, we have been using containers. Okay, which are very limited. Which are very limited. Okay, that means just we are creating one or two containers. We are starting. We are stopping. But when you want to manage these containers in production, so this kind of mechanism is not sufficient. Okay. So when we want to move containers to production, okay, so containers must, so what containers must provide? These features. One is fault tolerance. Guys, this is very important session, guys, because this is basic for Kubernetes. In whole course, okay, we have two important tools. One is CI/CD, other one is containers. Within containers, Kubernetes is most important. So fault tolerance. Fault tolerance means what happens what happens when a host running the container fails. Second challenge is what? High availability. High availability and scaling. How to handle load balancing. Okay, during uh, heavy usage of the application running in a container. Okay, manual. Okay, new updates. Third feature is what? New updates. So whenever new update comes, okay, so here every application will have a new releases. Okay, frequently. In such case, okay, so here in such case, containers must be updated to latest versions without any downtime. This is also very challenging issue. Okay, continuously developers will be writing code, and every time we are going to have new updates. Okay, when a new update comes, without stopping old version, my container must be updated to latest version. That is also very important thing. Okay, and manual interventions. That means here in case of application is having heavy usage, okay, we must be able to increase number of containers, and very less load is there. Okay, we have to decrease the containers, and along with this, so we have to also have monitoring capabilities, whether everything is working fine or not. Okay, so to perform above activities, okay, we need, okay, orchestration tool, orchestration software, okay, around containers, which solves above problems. So orchestration tool every orchestration tool should provide the following. What are the following, guys? Okay, automatic updates. That means whenever a new release has come, without stopping old version. So if old version is stopped, what happens here? My end user will not be able to access the application, right? Okay, when end user is not able to use the application, there is a big loss for the business. Okay, so we should not have any downtime. Automated update, automatic updates must be done. Automatic updates. Automatic updates means, okay, old version should not, okay, otherwise containers must run new version without stopping old version. How this is going to be done? Let us discuss. We'll discuss. Okay, and automated. Second step is what? Automated rollouts and rollbacks. What does it mean? Automated rollout means, so when your container is running some old version, a new version has come. Okay, we must be updated. Container must run a new version without stopping old version. Suppose old version is new version is not working properly. New version is not working properly. We must be able to go out to old version. That is rollback. Okay, self healing. Self healing means what? So whenever a container is killed automatically due to some hardware failure, okay, and the orchestration software must detect that, and within that failed container, so it should bring one more container up. Suppose I ask you to provide 5 containers always. Okay, it has to ensure that 5 containers are running always. So if one of the container is killed, failed, okay, automatically system must orchestration system must detect that one, and in that place, okay, a new container must be created by the system. That is nothing but self healing. Okay, and storage or service discovery, service discovery, and load balancing, load balancing. Okay, and storage orchestration. So yeah, these are the challenges. These are the features that every orchestration tool must provide. And when you move Docker into production, okay, Docker will not provide all these features. Docker will not provide all these features because Docker is having some limitations. So when I want to move containers, okay, we must have to, okay, have these features. So to provide these features, we need a orchestration tool. Is the concept clear, guys?
Yes.
Now let us understand one situation here. This will be very interesting situation. Suppose I have one application running in production. Let us say the application is something like e-commerce application, and everyone knows that e-commerce application is not a single application. So it is a combination of many mini services, like we have net banking and database module and something like authorization, okay, cache modules, and something like login, delivery module, and the second one is payment. Okay, just for the sake of simplicity, I have given only 7 services, but in reality hundreds of services running under e-commerce application. Now just imagine per service, okay, Here we have 7 services, right? So per service, okay, I have created 10 replicas. Okay, so here per service I created 10 replicas here. 10 into 7, just to maintain high availability. Okay, yesterday also we have created 5 Nginx services, right? In the similar manner, okay, to maintain high availability, okay, I have created 10 replicas per service. Okay, we have 7 services here. So 10 into 7 equal to how many? How much? 70. Suppose there are 50 services. Okay, for each service I created 10 replicas. 10 into 50. How many replicas you have to manage? 500. But managing 500 replicas, is it that much easy? It is not, definitely it is not that much easy. Okay, if 1 or 2 containers, if 1 or 2 services are there, we can manage them. Okay, so we can manage when 1 or 2 containers are there with the help of Docker. And to manage this kind of bulk amount of containers, okay, we cannot use containers, we cannot use Docker. Okay, so here the comparison between containers and the comparison between Docker and Kubernetes, just like what? Pet versus cattle. So pet versus cattle means cattle is something like, okay, Kubernetes means here we have so many containers. To maintain this containers, we need a orchestration system. And in case of pet, what happens here? Only limited pet animals are there. We can manage them. And to maintain a cattle, definitely a guy is required. Okay, so his responsibility is to take care of cattle. Okay, so the situation of cattle can be compared with Kubernetes, and the situation of pet can be compared with Docker. Okay, now, so here 7 containers are there, right? Now, what I will do, for every container, I will assign a service. Container, Docker container clipart. Let us take one container image here. Here, just imagine that these containers are running in 2 nodes. Okay, I have few more nodes also. Okay, 4 plus 4, 8. So suppose this container is managing net banking service, net banking, and this container is managing DB services, and this container is responsible for running authorization service, and this container is responsible for running cache module, and this container is responsible for running login module, and this container delivery, and this container is for payment. This container is something like, did I give cache? Authentication. Like this, containers will be running on different nodes. Suppose that this is my node 1. This is my node 2. Nodes are nothing but virtual machines. This is my node 3. And this is my node 4. Okay, just for the sake of simplicity, I have taken only 8 containers. but per service, what I told here, 10 replicas are there. 10 replicas, 70 replicas I cannot draw here. Okay, maintaining 70 or 500 replicas is not that much easy. Is not that much easy. Okay, so for that definitely we need one orchestration tool. Okay, is the concept clear, guys? Why and what
Yes.
is Kubernetes? What is the need of orchestration system?
Yes.
Now, when it comes to Kubernetes, so there are majorly two components are there. Kubernetes architecture. So here one manager node is there. All other nodes are worker nodes or no, simply nodes. So my manager node, this is my manager node, manager, and here this is my suppose node 1, and here this is my node 2 suppose, and here this is my node 4, and my manager node will be communicating with each and every node. So here one difference between Docker Swarm and Kubernetes. Yesterday we have practically seen, okay, on my manager node also some services are running. But in case of Kubernetes, manager does not run any service. Manager responsibility is just to take care of nodes, to take care of nodes only. It does not perform any activity. Okay, it does not perform any activity, just it will take care of nodes, whether all row nodes are running perfectly or not. Okay, to distribute the load across nodes. Okay, that is the responsibility of node. And exactly this can be compared with your football match. So in the football match, okay, one person will be there, okay, who is eagerly waiting, who is feeling seriously, okay, whether all players are playing correctly or not. Okay, who is that guy? Coach. Okay, so when one of the player is injured, okay, what happens, sir? Is going to replace a new player. So the coach can be compared with your master, manager. Okay, and these all these nodes are like players. So is the comparison understood, guys?
Yes.
Now here in node 1, node 2, node 3, what happens here? Here we are going to run pods. In Kubernetes, the basic unit that we create is pod. Kubernetes pod clipart. Here pod is the basic unit that we are going to create. So every node will have one or two, no, one or two pods running. So this is basic architecture of Kubernetes. We share this now. 27 May, DevOps, 7 a.m. IST 2. Now, so every node contains pods. Okay, within pods we have containers. I will repeat once again. Every node will have pods. Within pods we can have containers. Okay, so container is a part of pod. Okay, one pod can have one single container or multiple containers. So here, in Docker, how container is given IP address. Here, pod is given IP address. Pod is given IP address. Okay, so here the basic and the smallest unit that we can create in Kubernetes is pod. Okay, these are all the pods. Pods will contain containers. Pods will contain containers. Now, how my system is going to work? Okay, how my master or manager, I think it is master, not manager. We are going to call it as master, not manager. Sorry. It is master node. So how my Kubernetes master and nodes will be communicating with each other? Okay, that is very important thing. Okay, so for that we have to understand the 7 components of Kubernetes. The 7 components of Kubernetes. So what are the 7 components of Kubernetes? Now on master node, 4 components are running. Okay, one is kube API server, and another one is HCD. So this is also known as cluster store. It's just like database for your whole cluster. Cluster store, it is also called as HCD. Second one is kube scheduler. Next one is kube controller manager. And every node contains 3 components. Every node contains 3 components. One is kubelet, kube proxy, and container runtime. Container runtime. Okay, so every node contains these 3 components. So node 1 contains these 3 components. Sorry, what happened to this? Rectangular selection. This will also contain 3 nodes, 3 components, and this will also contains 3 components. Every node contains 3 components. Now, what are the responsibilities of these 7 components? 4 components are working in master, and 3 other components are working in node 1, node 2, node 3. Okay. Now, when it comes to master components like kube API server, cluster store, kube scheduler, kube controller manager, okay, these are the 4 components that are working in master. Now, master is going to take inputs either from YAML file. That means we have to know something about YAML. YAML is one kind of data representation. Okay, and here in Docker, when you want to have something, okay, in yesterday's class, so when I want to create 4 or 5 containers, just have executed one simple command. Here, using that simple command, you can create all the objects. but that is not a good way. But in Kubernetes, we are going to write something like manifest. Manifest. Manifest can be written in the form of YAML file. Manifest can be written in the form of YAML file. All we have known Ansible, right? Okay. In Ansible, you have learned the YAML. So in the YAML format, we are going to give input what we want. Okay. How many pods we want, and within the pod, what application must run. Okay. What is the port number that we are going? So that kind of inputs we are going to supply from YAML file. So this is also called as manifest. And we can also give input from REST API. So this is actually Kubernetes developer job. It is not our area. Our area is YAML file. And here Kube API server is going to take input from YAML file. Kube API server responsibility is to take input from YAML file. So YAML file is going to describe, okay, like how many parts you wanted to have, what is the desired state, and what the application must run, what is the port number, what is the volume. So that kind of complete information can be mentioned in YAML file. Okay, and that input is taken by Kube API server. Cluster store is going to maintain, okay, database. Okay, it is only it is going to know how many parts are running, how many containers are running. That kind of complete storage information is stored in cluster store. Now suppose here in YAML file, I said that 5 Nginx containers must be running. Okay, so this is called as what? My desired state. Desired state. So who is going to create 5 Nginx containers here? It is a Java Kube scheduler to schedule pods across nodes. Okay, it is going to verify which node is eligible for scheduling new pods. It is going to verify everything. It is going to create 5 pods across nodes. And when 5 pods are running, okay, if for some reason one pod is completely deleted, if one pod is failed, immediately Kube controller manager will come into picture. It will notify, okay, that one pod is missing. Then immediately Kube scheduler will come into picture. It is going to recreate that pod. That means Kube controller manager responsibility is to ensure that always that the desired state is maintaining. Here the desired state is what? Here 5 Nginx servers must be running. This is the desired state. So always Kube controller manager is going to ensure that always the state desired state is managing. This is the responsibility of Kube controller manager. Now, so these are the 4 components that are working in master. Kube API server is going to take input from YAML file. Cluster store is a database. Without cluster store, no cluster here. Okay, so it is a heart of cluster. And Kube scheduler is going to create as many parts as you want. And Kube controller manager is going to ensure that always the desired state is maintained. If not, immediately that is intimated to Kube scheduler. Kube scheduler will recreate such pod. Now when it comes to node, kubelet simply it is going to obey. Okay, it is going to take the order from manager, master node. It does not do any activity. Now what is kubeproxy here? Kubeproxy is a responsible component, okay, which is going to take care of network between master and nodes. Okay, giving IP addresses, giving maintaining proper network connection between master and nodes. That is the responsibility of kubeproxy. And container runtime means my Kubernetes can work with any container runtime. It need not be Docker. It can be any other container runtime software like Rocket containers. Many other container softwares are in the market, but Docker is popular one. Okay, so container runtime responsibility is to download the images. Okay, suppose in my Nginx file, okay, I said that I need 5 Nginx containers. So it is going to download the images. So it is responsible for starting and stopping containers. Okay, yeah, these are the 7 components that are working in your Kubernetes cluster. So what is meant by cluster? Combination of one or more masters. You can have multiple masters also to manage high availability. Okay, and you can have one or more masters, but definitely we are going to have multiple nodes. So combination of collection of this uh, one or more masters and more nodes will be called as what? Cluster. Cluster will have a functionality. Is the whole concept clear, guys?
Yes.
Now, suppose this is your Kubernetes pod. It is not node. Okay. So here I will take this as a pod. In the previous example, rectangle was node, but here it is. You have to imagine that this is your pod, and pod can contain containers. Docker container clipart. And one pod can have multiple containers. I told you. Now this can be your Nginx container, and this can be yours MySQL container, and this can be your Apache container. So this is what my pod, and pod will get IP address. Okay, not containers. So suppose pod's IP address is 192.168 and 0.2. So giving IP addresses to pods, that is the responsibility of kubeproxy. Kubeproxy is responsible for giving IP addresses to pods, and it also ensures that okay, there is a proper network is established between master node and nodes. Okay, actual nodes. This is actual architecture. Okay, one pod can contain multiple containers. Now, suppose here so we have one container running. So that is something like your Nginx container, not otherwise take Tomcat container. Okay. And here I have one more container within the same pod. So if a pod contains multiple containers, okay, so this approach is known as tightly coupled. Tightly coupled. And tightly coupled generally Okay, it is not recommended by Kubernetes. Kubernetes recommend is that, okay, we have to create only one container within one pod. So in some cases, definitely there is a need of creating multiple containers within a single pod. So in such case, okay, so here one container can be your main container, and another container. So this is something like log collector of Tomcat. Okay, so when Tomcat is running, some logs will be generated, and the responsibility of the second container is called as what? Log collector. So in this case, this is called as a sidecar container. Sidecar container, and this is called as main car container. Main car container. So main car container actually it runs application that can be Tomcat or that can be Java, that can be .NET, whatever it may be. So when application is running, some logs are generated. So that logs can be collected by this sidecar container. So only in this case of log collection, you can create multiple containers within a single pod. So is the concept clear, guys? So far.
Yes.
Okay. Now, when it comes to Kubernetes installation, so we have so many ways of installing Kubernetes. Okay, one popular way is what? kubeadm. Okay, kubeadm and kube spray, mini cube. Yeah, these are the ways. Mini cube means okay with one node only, one master, one node will be there. That is very simple installation. The kubeadm. So this is this approach. This is the approach given by Kubernetes community, and especially it is suited for dev and test environment. It is not suitable for production. Okay, so this is also called as manual installation. So to install this Kubernetes, it might take more than 1 hour time. That depends on how many nodes you are installing Kubernetes. So this is completely manual installation, and spray is also one kind of installation. But the kubeadm is very popular, especially it is used in dev and test environments. Okay, this is also called as manual installation. We have to install many steps, just we need to copy paste. So here to install Kubernetes using kubeadm, a document is given to you. Okay, according to that documentation, you have to do every activity. Kubernetes, not Kubernetes, kubeadm installation. So this is kubeadm installation. This is official documentation given by Kubernetes community. And according to this, refer here. So according to this, we are going to follow the steps. So before you are going to proceed to installation, we have to ensure that okay, every virtual machine must have at least 2 GB or more of RAM, 2 CPUs or more, full network connectivity between all machines, because in the cloud platform definitely network is maintained, and we have to open certain port numbers also on master node and nodes. Okay, so control plane means master here. We have to open these port numbers on master, Rather than opening every port number, we are going to open all the ports. These are the ports to be opened on the worker nodes. But this is completely limited to your dev and test environment, QA environments. But when it comes to production, okay, so above installations are for dev and QA environments. Definitely, we don't use these manual installations on production. Okay, so in production, okay, definitely every organization uses Kubernetes on cloud as a service. So every cloud will have Kubernetes as a service. Okay, there we need not to do any manual installation. All we need to do is how many masters are required, how many nodes are required. Within 5 minutes, 5 to 10 minutes, your cluster is ready. Okay, so every cloud is going to offer Kubernetes as a service. When it comes to AWS, so yes, there is a service called EKS, but here this is not that much popular. So here this stands for Elastic Kubernetes Service. Again, this takes a lot of time to set up the cluster. Again, this is equivalent to manual installation. But one popular way is there, that is AKS, that is Azure Kubernetes Services. 90% of the people in the industries are using Azure Kubernetes Service, not EKS, because EKS is having many drawbacks. It is very expensive and it is very difficult to set up. And when it comes to AKS, okay, Azure Kubernetes Services, okay, we have many advantages. Okay, what are the advantages of Kubernetes on cloud? Advantages of K8S means Kubernetes. In between K and S, we have 8 characters. Advantages of K8S on cloud. No manual installation, and it is available as a service. Okay, automatic updates. Today we are using 1.23 of Kubernetes. After 2 days, a new version has come. Okay, automatically you can take your cluster to new version without making much changes within 5 minutes. Automatic updates. And next feature is what? It is very easy to configure. It takes not more than 10 minutes. But if you want to set up Kubernetes manually, it takes hours. But one more thing, you are not a person to set up Kubernetes, even it is manual installation also. Okay, because if your company is a very old company, okay, somebody was setting up Kubernetes cluster, your responsibility as a DevOps engineer is to write, okay, YAML files, manifest files. Okay, your responsibility is not to install, not to set up Kubernetes cluster. Okay, and one more advantage is what? We can pay for worker nodes only. Okay, we pay for worker nodes. We need not to pay anything for manager node, master node. Again, one more important point, master node, it is not in our under control. Master node, it is completely managed by cloud service providers only. Okay, so here in Monday's class, we are going to configure AKS. How you can configure AKS and what are the objects that we are going to create on AKS, how to set up AKS. Okay, that we are going to see. And in Monday's class, I suggest you to create one Azure free trial account. That is valid for 12 months. So all you need to have is one debit card is required, debit or credit card. Okay, since you are in USA, okay, so it will also work with the debit card, debit or credit card. So if debit card is not working, try with credit card. And one email ID is required and one mobile number is required. So once you create a free trial account, okay, in your account 200 200 worth of US dollars will be credited. So 200 US dollars, this is valid for 1 month. 1 month happily you can use unlimited services. You can enjoy the services. There is no charge for 1 month. But how to create a Azure free tier account? Free tier account creation. This is a link, guys. You are seeing this one, right? Start free. Here we will be asking your username. Okay. Use another account. What is your account? Better you have Hotmail or Outlook. Okay. Enter your account details. In the next page, it is going to ask your personal data. And the next page, it is going to ask you card information. Okay. Like your card number, name on the card, validity, CVV. Okay, so initially $1 or $2 will be cut from your account just for your account verification. After 48 hours, the deducted amount will be refunded. And once your account is created, so this is the home page of Azure. I'm not going to take up AWS because AWS is not used by many people. Okay, most of the people across the world are using AKS only, not EKS. This is your home page of Azure. Once your account is created, you must be able to log in into this page. So on Monday session, we are going to discuss how to set up Kubernetes cluster AKS. Then we are going to start writing our YAML files. Before that, let us so you better refer once again YAML, because exactly YAML syntaxes we are going to use, because all you know YAML, right? Because we have learned YAML in Ansible. Exactly, it will be like that. Okay, so is everything clear? Today we have discussed many topics. The people who did not attend this class, please go through this recording before coming to next class. So if you come to next class directly, it is exactly like Greek and Latin. And I am so informing Ghalib and Mehboob and Mosharaf, please inform your friends, okay, to watch recording before coming to next class.
Sure, we will.
Without that, definitely things will be confusing, because today we have discussed many things. What is the need of Kubernetes? Okay, with the live examples also, and architecture and installation methods, everything we have discussed today. Next class directly I am going to create cluster in Azure.
Okay.
Cluster creation is nothing. It is a matter of 10 minutes. By Monday, everyone has to have Azure free tier accounts. Okay, so it is a benefit only. You need not to pay anything. 12 months you can use, but in the first 1 month you are going to get 200 worth of services, and whatever services you are going to create, everything will be deducted from 200 US dollars only. You need not to pay even single dollar to anyone in the first 1 month. So first, from second month onwards, if you are interested, you can use that. Otherwise, you can close a Azure account. From second month onwards, what happens here? Your plan will be changed to pay as you go. For first month only, it is going to under free trial. Okay, if you want, you can convert it to pay as you go. Otherwise, you can simply close the accounts. Guys, please inform your friends that please ask them to watch the recording of this session. Okay. Once again, I'm telling, if they come directly to the session, they are not able to understand anything. That is not my responsibility.
Shiva, they are going to watch it. What happened over here is a Friday night, so weekend night most of the time. We have actually some kind of invitation, different places. It's a family night basically, so that's why. But definitely, all of us going to watch this video again, and when we
Hmm.
come back Monday, inshallah, we all will be prepared for the class.
Yes.
Okay,
Okay. Just please inform them. Okay. Then we
sure,
meet on Monday again. Okay. And
sure.
still, if you have any questions, is till this point is everything is interesting, right? Everything is
Right.
clear.
Yes. Wonderful. Everything is clear.
Yeah. Yeah. Thank you. We meet on Monday
You're
again.
welcome. Yeah, inshallah. Have a
Have a
wonderful
happy
weekend.
weekend.
You too. Thank you. Bye.
Bye.